Welcome students for Chemistry in Everyday Life, Part 2nd. In this video, we shall study about chemistry in medicines and analgesics. Chemistry is involved in medicines, and chemistry also finds application within the food products, and even students, chemistry is involved in various detergents and the soap which are used as a cleansing agent. Let us discuss in detail about chemistry which is involved in medicines. Various medicines which are used in day-to-day life. The first, analgesics, tranquilizers, antimicrobials, anti-fertility drugs, antacids and antihistamines. Let us first discuss in detail about analgesics. Analgesic, students, reduces the body pain without causing impairment or damages of consciousness, mental confusion, incoordination of muscular activity, and even the paralysis. Thus, we can conclude that analgesics relieve pain by acting on central nervous system, it is called as CNS, without loss of consciousness or without much disturbing the nervous system. Further, students, analgesics are of two types. The first one is narcotic analgesics, whereas the second type is non-narcotic analgesic. Now, question arises, what is narcosis? Narcosis is a state of deep sleep. Certain analgesics which induces a deep sleep and relieves the body pain. So such kind of the analgesics come under narcotic analgesics. But student, certain other analgesics which don't cause the deep sleep within an individual but relieves the pain. Such kind of analgesics are called non-narcotic analgesics. Now, let us understand what are the major differences between narcotic and non-narcotic analgesics. Narcotic analgesics, students, these drugs produce narcosis, that is deep sleep, when the person consumes non-narcotic analgesic, it induces a deep sleep. Whereas non-narcotic analgesics, they do not produce narcosis. Second point, narcotic analgesics are very potent drugs. Students, here potent drug refers to highly efficient medicine. By inducing the sleep within an individual, these narcotic analgesics can very easily reduce the pain. Whereas non-narcotic analgesics are not potent drugs. In comparison, students, if we compare narcotic and non-narcotic, so non-narcotic drugs are relatively less potent. Next, students, in narcotic analgesics, their chronic use leads to addiction. If the person is continuously consuming narcotic analgesics, then the person would be having an addiction towards that medicine. whereas non-narcotic analgesics do not cause such kind of addiction towards the medicine. Next, narcotic analgesics are central nervous system depressant. In this case, student, the narcotic analgesics, they are directly acting on central nervous system of the human body. Thus, it relieves the pain and induces the sleep. Whereas the non-narcotic is not acting on CNS, thus they are not central nervous system depressants. Examples for narcotic analgesics are opium and its products like morphine, codeine and heroine. Whereas examples of non-narcotic analgesics which we commonly consume is the crocin and aspirin. Now students, we shall study in detail about narcotic analgesics. They produce the depression of only the nervous system and relieve pain instantly. So the nervous system is getting depressed and in return, student, the body pain gets relieved. Examples: morphine, codeine and heroine. Now students, question arises when we are consuming the narcotic analgesics, and the answer for this is reduces the pain during the fracture. That is, consumption of narcotic analgesics, it reduces the pain, it reduces the severe pain during the fracture. And student, after the operation, the post-operative pain can be reduced by the consumption of narcotic analgesics. And even student, the pain which is due to burns. In this case, both epidermis and the dermis of our skin is severely damaged and the subcutaneous tissue of our body is exposed. Such a kind of severe pain can be reduced by the consumption of narcotic analgesics. Now students, let us study about some of side effects of consuming narcotic analgesics. And the first one is the person gets addicted for the drug. Second adverse effect is vomiting, dysphoria, fatigue and even mental confusion. Now let us see structures of some examples for narcotic analgesics. The first one, student, it is a morphine with the molecular formula C17H19NO3. And students, very easily you can draw the structure by considering the 3 cyclohexane ring followed by writing the other parts. In morphine, students, we can find it is having one of furan ring and even 2 hydroxyl groups. Let us consider second structure, that is codeine. It is an alkylated morphine. So structure represents the codeine molecule with the molecular formula C18H21NO3. If you remember, student, structure of morphine, in this case one of OH group has been alkylated, that is methyl group is placed instead of hydrogen. Now very easily you can draw the structure of codeine molecule. In this case also, student, it is having the 5-membered ring of furan along with 1 OH group, whereas 1 OH group has been methylated and the rest of the parts remains the same as that of morphine molecule. Next example is the heroine, which is acylated morphine. In this case, student, if we consider the structure of morphine, on either side we were having OH groups. So both the hydrogens are replaced by acyl group. Acyl group means COCH3. So on the either side you can see the presence of acyl group. And the molecular formula is C21H23NO5. Students, you can draw the structure of heroine also in the same manner as we did for morphine, but in this case OH group is replaced by OCOCH3 on the either side, and the rest of the parts remains the same. So remember, we are having three examples. The first one is the morphine, the second one is the codeine, and the third one is the heroine for narcotic analgesics. Now students, let us consider non-narcotic analgesics. For example, it is aspirin compound. Non-narcotic analgesics, they are mild analgesic, refers to they are not a strong agent but they are weaker analgesics. And students, they are antipyretic and even they can be used for anti-inflammatory reactions. Thus, the application of non-narcotic analgesics is it can be used in headache, cold, tissue swelling, etc. Let us study now aspirin synthesis. And for this, student, we require reactant as salicylic acid. In salicylic acid, we are having COOH, that is acid functional group carboxylic acid, and at the ortho position OH group. So the molecule is salicylic acid. When this is treated with acetic anhydride, the molecule acetic anhydride CH3COOCOCH3. So it is acetic anhydride. In this case, when salicylic acid is reacted with acetic anhydride, student, removal of phenolic hydrogen occurs and replacing by acyl group, that is COCH3, we get aspirin molecule. Thus, if you compare the molecule, student, salicylic acid and the aspirin, hydrogen has been replaced by the acyl group, that is CH3CO, by means of reacting with acetic anhydride. Thus, students, the formation of OCH3 group is a methoxy group, whereas CH3C double bond O is acetoxy group. In aspirin molecule, we can see acid group, carboxylic acid, and even acetoxy group which is present. Thank you, students. In the next video, we shall learn about tranquilizers, antimicrobial and antibiotic drugs. Thank you.